In this video, we'll see some ways to build on counting and summing to solve larger problems. So here is a program that asks the user how many values to add up, and then uses the user's input to control a loop. The loop enters that many values, accumulates them into a variable, and shows them out. So this is a summing program. Compile, run, and let's say we have three numbers, 19, 12, and 5. Adds up to 36. All right, so once you have a total and a count, count here is given by the user, right? We can calculate other things. For example, an average. Right? Now, an average is always a floating point value. So you calculate, you set that up with a double, right? And it's just the total divided by the number of values, which in this case was provided by the user. Right, but this is a trap. There's a gotcha here in Java because total is an int, num to add up is an int. Right, so this right-hand side here is integer division. So if this was constants, we could just put 0.0 on something and make it that, but it's not. An easy way to remedy this is to multiply the numerator by 1.0. And because the multiplication takes place first, right, since we're multiplying by a floating point number, this will be a floating point number. And then we'll do floating point division. Notice that you won't get the same result if you multiply after the fact, because this will happen first and you will have already dropped the fractional portion, right, before you turn it into a float. So it has to happen first. All right, so we'll do this two ways. Just to add up, and we'll do one that doesn't use the 1.0 at all, and we'll see the average trunk total to add up. All right, so we have three different alternatives here. All right, just dividing the total by the count, multiplying by 1.0 before we divide. All right, this is actually the only one that's correct. Or multiplying by 1.0 after we do the division. All right, so we're going to see all three of these. So let's do use some small numbers so the answer will be a little more obvious. 7. Oops. I want to add up that many values. I want to add up three values. 7, 3, and 5. Okay. Total is 15. There's three numbers. So in this case, right, it happened that all three values happen to be the same. Because there is the actual average has no fractional portion. The fractional portion is 0. But what happens if a little bit off? Let's say we have three values, 8, 3, and 5. Okay. So now we see the two incorrect answers, right? The actual average, right, of 8, 3, and 5 is 5.3, right, as a repeating decimal. Right, but if we don't change it into a floating point value on the right-hand side of the assignment, right, we lose it. Right? If we multiply too late to change it to a double, we lose the portion. Right? So bear that in mind when you doing any kind of division with integers. Right? You have to just think about whether or not the problem requires you to keep the fractional portion or not. Right, so I'm going to delete these incorrectly and just have a correct version of the values to add up. Okay, so 3, and what were they? 5, 3, and 8. All right, so the order obviously doesn't matter. All right, so next, another thing you can do with counting and summing is growth tables. So I'm going to start a new program for this. 3 things you need to know for a growth table. So first thing is your initial population. All right, so suppose we're modeling population growth of some animal in a game preserve. All right, so we'd start with some population, and say there's 300 individuals, 300 animals to begin with, and then we need a rate of increase. All right, so double rate, and let's say it's make some high rate that so we can really see the effect each year. So that's 15%, right? And then you need to know how many years to predict the growth, to calculate the growth for, and let's say we'll do for 5 years. So the years on a growth table are the periods, right? That's the loop bound. So we have a loop for int y equals 1, and it's convenient to start at 1 and go to less than or equal to years. And of course, we want to do 1 at a time. So each year, we will calculate a growth. So we'll calculate the growth as the population times the rate, right, and then add that growth to the population. So we say population now equals population plus the growth. And then you want to display this within the loop, right, because we want to see this value and the changed population for every year. Right, so we have an output statement. Let's take a look at that. And the numbers are skewed, right, because Java on its own decides how many decimal places to show on a particular value. But you can see from the whole number portions, right? The first year we started with 300, a population of 300 with 15% growth. Right? So in the first year, 45 new individuals, so the population at the end of the first year was 345. That causes bigger growth the second year. So we had 51, almost 52 new individuals the second year, and that's added to the new population. Now the bigger population, calculating a percentage of a bigger number, so we have more growth. Now, something like this is a good use of formatted printing, so you can keep control of the decimal places. So that would look something like this. We'd need, when I say 4 spaces with 1 behind the decimal for the growth, and let's say 5 spaces with 1 point behind the decimal for the new population. And comment this out and see what that looks like. And there's the growth table. That's much easier to read. All right, so only thing we need here is column titles. All right, so that goes before the loop. And we may have to adjust the columns a little bit to make things line up. You have to look at it first to see, where things have to go. And there you go. That's a growth table.